the session to help for reference later on. Good. Yes. Good. Perfect. So Autodesk, all right. For majority of people on the call today, I know definitely you would have an idea who we are, but generally, I would like to maybe help you understand Autodesk better. So typically it's that industry leader that help, yeah, industry leader that makes software for people who make things. So literally anything at all. So if you've been in a fast car, seen the most awesome movie with some CGIs or VFX, or been in any kind of wonderful infrastructure, whatever it is, from the oil and gas space to the road bridges, highways, to whatever it is, chances is that you're already experiencing what our customers are doing, or like peculiar to people on this call, chances is that you are already um, having a feel of what our technology can do. So for the last 40 years, we've really transformed this industry, right? You know, with the first revolution from the conventional or traditional drafting system, Autodesk really was quite material to the invention of CAD, computer-aided design with AutoCAD around probably the 1985s, right? And we've been working with industry to enable you design and build whatever it is, right, through the better use of data. And after that, we've transitioned to BIM, right, which was quite awesome. You know, when you look at how much disruption and how much optimization, you know, got into that space, all right, especially for the AEC industry. Okay. And with the advent of COVID and probably, you know, before COVID, all right, the need to really transform the way we work, not just what we do, not the work we do, but the way we work, the way we collaborate, all right, which was quite pointed out or escalated by COVID itself. But you see that cloud collaboration, you know, integration, end-to-end connection, all right, during the workflows that we call the AEC design workflow became very important. And then eventually, as of today, the conversation is all around AI, machine learning, how these industries can, you know, be transformed, how we can take better decisions, how we can evaluate more options, how we can even spend the most minimal time doing the best amount of work. Okay, so but one unique thing about this is they were all, you know, specific disruptors, and as we continue going on today, you see that we need to continue on this trend, and this is why what Autodesk is really helping us to do. But in a nutshell, and this whole journey of digital transformation, all right, I would like to summarize it in with this four major um journey, which literally is to help you digitize what you do. All right. By digitization, you know, we're talking about combination of having the best technology solution, you know, to being able to win better with time, cost, and every other thing surrounding these two factors. And importantly, to connect why we're doing this. Sorry, why we are doing this. So one of the things you're going to see later on is how complex projects are becoming today. All right, you see that more stakeholders across globe, across cultures are becoming involved in projects. So you see, it's very important to uniquely, you know, connect with everyone. And we can't talk without emphasizing the importance of optimization in what we do. All right, whatever we need to do, we need to do better. Okay, and then at the end of the day, evolve, have companies who now have a couple of diversification, you know, much learning, technology transfer, and so on and so forth. But let's dive into what we have to do. You know, when we look at the plant industry uniquely, my presentation is just basically going to touch a couple of things Autodesk is doing in this space. All right, looking at this typical workflow around the plant industry, which involves a couple of general design and drafting, you know, a couple of PNIDs and plant design, you know, all the pre-process, the hazards and whatever happens at the early stage of um, the design, you know, process. And it also transitions down to as much as 3D modeling, documentations, equipment designs and skid, but whatever it is, at the end of the day, you see that this whole process are uniquely optimized by a couple of even sandwich processes, all right, like design review, coordinations, and so on and so forth. That's why I found it very interesting and important to put collaboration as a major thing. But looking at all of this and looking at the industry generally, you see that one common thing about this space is, it's unique for aging infrastructures, aging facilities, and that particular trend of course highlight one of the key trends we have today called reality capture. I think one of the speakers would touch around that, all right, especially as it has to do with reverse engineering. And we're seeing also emerging economies, all right? Economies were becoming more robust, increasing demand. Of course, when you look at the population demand, from 2050, you see that economies like we have in Nigeria and sub-Saharan Africa will continuously adopt, build, initiate new projects. So another thing is if we need to compete on the global scale, all right, if we need to work with most of these new projects, we also need to be up to standard. We need to meet a couple of compliances, and it's becoming important, all right, not just in the plant industry, it's uniquely around you every day. There is the need and the call for compliance. So economies like that of South Africa, that of UK, all right, and co, all adopting BIM mandates, all right, and similar mandates to help industry leaders check, okay? And uniquely, these projects are always with shorter timelines and, of course, tighter margins, which is unique with the construction space. So all of these trends are quite unique for this space, and we're seeing expertise retiring, the conventional, the veterans, all of course leaving the space. There are acquisitions, talent needs to come in, we need to grow the talent, we need to grow the knowledge. And even when we are doing this, you see with what is happening, even the digital competencies become quite important. Like today, we're seeing a lot of integration of AI processes in a couple of things we do. And finally, all right, things need to be consolidated. People need to work together. You can't really say or force a couple of industry leaders to use specific systems. So it's very important that all of the systems integrate with each other, and you can have a common goal. Just like this trend, there are a couple of business challenges that uniquely unify all of the players in this space. I already mentioned the importance of the fact that timelines are shorter and margins are of course smaller. You see that with this project, the challenge to also meet all of these projects in a short period of time is quite important. There is also the challenge for skill and resources, of course. When we're talking about design, engineering, all right, these things are not, these are not skills that are found everywhere. So you see that availability of those things, of course, is becoming quite important. Errors, reworks, cost of wastage, of course, are pretty challenges. And these are things that happen, especially when organizations do not have a 360 overview of what they're going into before they go into it. And finally, projects are becoming complex, all right? Complex in system, complex in the number of people working on it, all right? Complex in the scope, all right? Complex in how diverse the entire team on the project are. So when you look at a couple of projects you have in Nigeria, for example, you see that, from the project owner to the consultants to the maybe architects, if the case may be, structural engineering company, consultant, everybody's coming from different economies, different cultures, all right? And everybody needs to work, all right? And as even this is happening, you see that a couple of your stakeholders in the project necessarily might not even see themselves throughout the life cycle of the project. So it becomes quite important, um, um, the fact that we need to work and have a better way of working. And at the midst of all of these things, Autodesk has innovations and technologies, especially what you're seeing around building information modeling, called BIM in short, which is necessarily uh, I like to see this as a culture, a way of life. Whole lot of people have asked questions around whether BIM is a software or it's a tool or it's some tangible thing. But generally, I like to see BIM as an attitude, all right, which involves coordinated workflow from the start to the end of a project, or necessarily, when I say start to end, it's often make it look like it's a linear process. It's actually very cyclic because some projects continuously through even the operation stage are recycled, all right? Okay, so building information modeling is just that attitude enabled by technologies that help you coordinate data from one stage of a project to the other. So from, let's say, the surveying stage, the land development stage, down to the start of maybe architectural design, to the start of equipment design, to piping design. So everybody keep plugging into the same data, and of course the same data is totally colorated across the team. So it's all enabled by sets of technologies, led by, industry leaders in this software industry. But I really like you to understand the fact that it's more of a process, because you see organizations adopting this best technologies that are all BIM enabled, and yet they really aren't BIM compliant, simply because they are not really aligning with the attitude of BIM. So connected BIM now is more of adding this to the power of cloud. It's a cloud enabled, intelligent based process that unites design, build, and operate segment entirely. Now let's drive down to what we have today, which is necessarily plant design solution, all right, enabled by a set of collection of software called AEC collection at Autodesk. So firstly, I would like to approach it by a typical workflow throughout the plant design stage. Firstly, the concept development stage, which necessarily you can see as the conception stage. And at this stage, a major concern is always to maybe start up with a quick P&IDs that are quite intelligent, because I mean this is one of the key issue we have in the space. P&IDs that are basic elements, basic geometries, um, of course, hard geometries that people just want to draw quickly. And it becomes quite problematic when there are calls for changes, when there are just little tweaks, all right, even at the early stage of the design. I'm not even talking about the stages, let's say HAZOP stage or design review stage, where major changes are made. All right, the question is how intelligent is the P&ID interface, the tools you use? And also we need to also mention how important it is to have spec-driven P&IDs as well. And whatever you're doing, it also needs to be spec-driven. And also, we also talk about efficiently performing the preliminary plant design layout and even share data. And there are a couple of solutions we're going to look at today, all right, which enable all of this. So basically, what you're seeing, tools like Plant 3D, InfraWorks, Recap, which is more like the short for Reality Capture 360, and Autodesk Construction Cloud will come into view when we discuss this. And at the next stage, you start looking at how we can start reviewing the P&IDs, right, and converting them or moving them into elements around elements in your models, right? 3D modelings, how you might want to link your P&ID lines to actual 3D piping, all right? We need to also start thinking about developing concise, efficient piping design, piping layout, and for when they also look at cases where reality capture comes in place, right? If you had collected some point cloud, you probably used laser scanners or some other related devices to capture data. You see that it's also very important how you need to start using those point cloud to capture the condition of the site, and then make meaningful decisions from there. And finally, you also need to develop the actual plant site, the structural design, the structured infrastructures all around on the project. So there are a couple of solutions you're going to also look at. Then optimization also calls to mind a couple of workflows around stress, analysis of a couple of components you have, especially from the structural point of view. And we also look at leveraging BIM, also BIM tools, BIM software for specific disciplines in your workflows, all right? Maybe there are MEP aspect of your design, there are architectural part of your design, engineering part of your design, and so on and so forth. So all of these things are quite important, and finally, in the coordination part of it, which also is one unique thing across the EPC space, all right, the need to connect every single person on the project, okay? Most of these projects have stakeholders or contractors or subcontractors managing different disciplines or different scopes of the project. And you see that at the end of the day, what becomes important now is how do you get everyone together on the same platform? How do you ensure that there is no clash, all right, when everybody comes to site? And this is actually a measure of reduction of error, reduction of wastage, and also reduction of wasted time. And also in this case, also if there are also point cloud elements, is also also a very good point to start validating them and working them out. So typically, all of these solutions are all within the AEC collection, as you may see. So as I mentioned, AEC collection is a collection of suites, a suite of software that fits couple of players in this AEC space with plant design industry also not excluded. So in a nutshell, we've seen classic workflows like P&ID design, as I mentioned, equipment design, piping design. You'll now start looking at coming up with a structural design that now integrates with everything, and design reviews, rendering, developing a couple of deliverables from pipe isometrics to plant layouts, orthographic drawings, and so on and so forth. So, but what I'm going to now go into now is making a case on how all of these things work, how efficient the systems are, and how you can leverage all of these things in your own internal workflows. Okay. Okay. Good. Just a minute. Okay. Firstly, typically what happens is, just a minute. Are you hearing any sound? Can you hear any sound? No. Are the audience hearing any sound? Are you hearing? So I actually want to take off the sound. Yeah, sorry.
No sound.
Yeah, no.
No
Okay.
sound.
So I'm just going to, I was disturbed by a sound from my system. Just let me resolve that quickly. Sorry. Sorry, just okay. So sorry about that. I'm just going to start over again. So at the first stage, most times the concern is land development, acquisition of land, or in the early stage of your project, you're not necessarily paid at that point in time. You want to just start up with conceptual design, tools like uh, infra works, right? Like what you see here can be quite material, especially when you're talking about presentation, linking the, the actual GIS system to the project site. You can see with InfraWorks, conceptual models of, typical infrastructure project can be done. But one unique thing about this is the ability for you to quickly integrate whatever you have as a conceptual design to the actual GIS system, All right. And, this can actually be taken into the next level. Imagine you have the reality capture of your site. You can actually embed it into the same system and as well embed the conceptual design of the model to have a feel of how it's going to look at the end of the day. But this is more like, what happens at the early stage of the project. I believe one of the speakers today, we also, threw some light around reality capture and about how some of these things happen. Okay. But I'm just going to get started with the okay. Sorry, I noticed my display is not showing again. Sorry, I think we're having a little technical issue, and I realized what I'm sharing is no longer being seen. Am I still with the audience? Okay, that's the virtual audience here.
Yes, you are.
Okay. Oh, okay, 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 okay. Sorry about that. Okay. It's for people in in the physical people that are having the challenge. Okay, sorry guys. We had a little bit issue with the projector screen. So I believe everyone online is seeing the screen. It's just the challenge is just with the people on site. So please, can someone confirm if someone from the Microsoft team Meet confirm if he's seeing what I'm sharing, and he can confirm that he's seeing AutoCAD PNID main features.
I think I can just see you. I
Only
can't
me.
see what you're sharing. Yes.
Okay.
Same here too.
Okay. Good. So good. Yes. So what we can do is reshare.
Share, yes. Yeah.
Okay. Oh, okay. It's already notifying us that it was. So I'm gonna share my screen to just make it very easy. Good. Perfect. Where's the PowerPoint? Is that it?
Should be.
Oh, not it. Perfect.
Yeah.
Good. Confirm if you can see it now.
Yes, we can.
Good.
Yes, we
Good.
can.
Good. So sorry about that. I will be faster now because I noticed that my time is even going up. So firstly, the PNID stage, all right. I know a couple of people know AutoCAD, but I'm not sure if everyone understands that AutoCAD comes with some specialized tool sets, right? When talking about specialized tool set, I mean beyond the typical 2D drafting and annotation abilities, all right, of AutoCAD. All right. I wanted to make sure that you understand. I think this keeps happening. I wanted to make sure that you understand the. Okay, good. I wanted to make sure that you understand what you can gain from using a typical AutoCAD license. All right. But the AutoCAD PNID, as I would just show now, is contained within AutoCAD. So I just wanted to clarify. All right. guess typically people will want to ask, okay, where can you find things like AutoCAD P&ID? So, but let's go back to what typically you can find with AutoCAD P&ID. First of all, mentioned intelligent P&IDs, right? Typically, people used to just use typical lines, circles, and blocks, combination of tools. Some companies also who do this repeatedly probably could have two palettes or related things to hasten their work. But apart from this, there is a set of features available for you to leverage industry standard symbols, lines that are intelligent and dynamic. All right. By intelligent and dynamic, I mean, imagine you're creating a line and you're able to assign specific information to those lines. All right. Example, probably the line sizing or the process information. All right. And subsequently place a valve or some inline component on the line. All right. So typically you should have some level of conformance, all right, or compliance to the existing spec. For example, if the line originally is a line of 4 inches, all right, it should, the valve or whatever you place should be able to immediately adopt such specification, all right? And in cases where you include things like reducers or expanders or whatever it is, those intelligent information can just be transitioned. But it's very easy. I'm still going to demonstrate how that works. All right. It's also very easy to manage components, everything. So there's things like data managers that can help you, quickly have an overview of what you have on your P&ID. Typically, people do count, and I think I know some valuation or estimation engineers just typically get tons and tons of P&IDs with off-page connectors, and then they start counting. These things are not supposed to be that way, because with P&ID, you can have a data manager that just quickly look at it. So there are a couple of things, you can gain by using that. Of course, you can export to other parties, but let's see how it looks like. So typically the interface, of course, is built on the traditional AutoCAD environment. All right, which means if you're used to AutoCAD, you can make commands, you can create commands. It's very easy. So you can set up standard, and for lines, you can specify typical specifications like sizes, the specs, and assign them so those lines become intelligent. Tagging system is quite important, and you have access to a robust data, two palettes that you can automatically pick. So these things make your processes easy. And as you're doing this, there is also a data manager who is busy collecting all the data as you're placing. Remember what I meant, what I said when I was talking about BIM. This is actually the essence of BIM, because as you're busy doing this, something else is busy collating and coordinating what you're doing. So it's quite important how this works. There are a couple of things you see here that are very critical, things like direction of flow. These are things you can play around. So this also integrates as much as instrumentation, a little bit of instrumentation, all right, and a little bit of components, all right, you can create. So one good thing about this is that the two palettes or the specs editors can really be also edited by the company. So as I already mentioned before, now you see that there is a data manager. So for example, you can just quickly export pump information on the entire project. And I wanted to also clarify that no matter the size of the site, all right, no matter how complex the P&ID is, you can still work around all of it here. The same system of off-page connectors link sheets together, connect sheets together, and all of these things are automatic, not just some typical AutoCAD files, just native AutoCAD files that you just stack against each other. So they are linked. There's a project manager who manages everything on the site, what you see on the left side of your screen. So all of these make your work easy and faster. And I would like to also stress how much critical this is, for workflows, all right, or what happens after, let's say there is a design review and there is a call for change. You see that there is going to be a drastic reduction in time spent implementing changes, okay, which is one of the bottleneck we have in this industry, okay. Okay, so I know why I'm doing this. A whole lot of people will have a couple of questions, but just get them together. All right, by the time we're done, towards the end of this, you'll have time to ask questions. Okay, I'm shifting over to the next thing. I also mentioned how important it is to copy and how intelligent the copy process is. So as you copy and multiply, automatically the naming convention, of course, is also automated. So if you're copying pump originally as pump 100A, automatically it's gonna annotate it as pump 100B. And of course, it maintains the intelligence, it maintains the connection, all right? And data as you build can also be exported to maybe the procurement team or whomever to also fill up data. And the same data that also has been populated by other stakeholders can also be re-imported, not automatically, but I mean, the designer or whomever is the originator now decides on what he accepts or not. Another aspect of what I've discussed also is the AutoCAD Plan 3D, which is also within the AutoCAD specialized tool set. Okay, and this AutoCAD Plan 3D, is there. It's included in this. You know, with this you can have your spec-driven routing. By spec-driven routing, I mean all of the pipings you're doing are also, you know, controlled by pre-existing specs. All right, these specs, yes, a couple of them come with the AutoCAD Plan 3D board. The entire software package has its own spec editor where the company can customize, you know, create their own specs and use. Design system is also parametric, so equipment design, vessels, whatever pumps that you want to have in your 3D models are typically parametric. You can just with some design wizards, just iterate between a couple of parameters around your dimensions. And another thing is within the Plan 3D, you just have a basic steel structural design, but you remember what you're discussing today is more of the AEC collection. So we are still going to look at other tools and technologies that help you specifically address structural design. One smart thing about around this is also as you're building up these things, very easy for you to generate MTOs or BOMs, as you might call it, bill of material. And uniquely, I would like to emphasize the rest of the things on the screen: isometric drawings, orthographic drawings, and so on and so forth, layouts. And you see, all of these things are interconnected. A couple of solutions out there require that you export, and then, you know, at some point there is a disconnect between the drawing sheet and the model itself. And, you know, imagine you have a design review where you presented a set of drawing that made up of 50 pages, and then you have to go back and make a couple of changes. You know, unlike, you know, here, what you just need to do is just quickly make the changes on the original model, and a whole lot of things update. So there are also workflows that you're going to see. I've already spoken about catalogs and spec customization. There is a total interface for that, where you can, an organization can manage their own specs. PNIDs are integrated to Plan 3D, so you can decide to link existing PNIDs directly to the plan design to ensure transition, all right, of spec. So maybe you want to draw a line, you want to model a pipeline or a pipe spool that you already have detailed in a PNID. You can just link it up, and all of the data are automatically generated. So a workflow like this shows that you can see how easy it is to quickly pipe. And as you're piping, you see what you have on the left, that little thing there is the different lines, all right, that come from the PNID, all right. Those were already defined by the PNID. So as the piping is being done, it's totally linked to the pools or to the lines. So those line information are automatically carried around to the piping. So by information, I mean the tagging, the sizing, whatever it is. So it's very easy for you to remain compliant to specs. Sorry. Just a minute. Let me duplicate my screen. Perfect. So you can remain compliant to spec, and everything goes on smoothly. Okay, good. So every other thing like support, as I mentioned, every other thing is totally parametric. It's very easy for you to modify, move, shift. And one of the unique thing about the Autodesk solution is how easy it is to navigate, how is it for you to edit, move things around. So this makes it very easy and faster, all right, achieving the optimal time. So a couple of other workflows, right? There is a solution called Autodesk Inventor originally at Autodesk. This is equipment design. It's for equipment design because it has unique design modules, all right, for equipment, all right. You can totally design from scratch, maybe vessels, all right. Considering, let's say, for example, sheet metal workflows. So when you look at sheet metal design and piping design, frame design, so some people just probably use a different software to come up with maybe their skid, whatever it is. So solutions like Inventor, it's not included in the AEC collection as you're discussing today. However, it's a unique solution for equipment design. So because it builds everything from the scratch, it has the same ideology of the workshop, of the shop floor, where things are designed part by part, parts assembled together, welds included, and you can just probably get those kind of models into your Plan 3D. So what I'm saying in a nutshell is, if the equipment or associated components or package you want to get into your plant design interface is coming from a third-party solution like Inventor, all right? So it's just for you to use Inventor to define some key points, probably connection points, and easily get it into Plan 3D. So the moment you get it into Plan 3D as a solution, which has, of course, it has a very simple workflow, you can quickly start piping from them or connect piping component from there. So also, I think I forgot to mention that the Plan 3D environment is quite easy, apart from the pipings, how easy it is to route piping. It's parametric. One, you need to understand that. Secondly, there are a lot of tool palettes available, maybe for you want to do copying, you want to do flanges, a couple of valve system. So it's very easy. And one unique thing about this workflow is you can also manage the environment, design disciplines. Example, you don't necessarily have to have all of the disciplines all in one AutoCAD files. Okay. The structural aspect can be managed in a totally different site. Equipment is managed in a different site. Piping is managed in a different site. However, you can just connect everyone together with things like external references. The conventional Autodesk user will understand what I mean. So you can just totally have everybody on the same interface, all right, taking information from each other without influencing or affecting or impacting the model from those guys. So what I'm saying is, all of these disciplines can go concurrently, but all of them seeing what each other, all of their works, So for example, let's say you want to pipe at the 500 millimeters top of steel. All right, you can just reference the top of steel from the structural design that is existing without mistakenly modifying what those guys doing. Okay, so I think I have to move over to the next phase, which start talking about deliverables. It's pretty easy for you to start generating things like pipe isometric from click of a button. And remember, one unique thing about Autodesk, just like if you used AutoCAD, you know that things like layouts, right? Layers, sorry, have been there to help you organize and stay coordinated. A similar workflow can also be adopted here, when you can actually, I'm not saying layers are what you use for it, but you can actually organize your piping into spools. So when you're now, or lines, sorry, the other spools are lines, so that when you're now generating things like pipe isometrics, like what you've just seen here, it's going to be very easy for you to call it up, call a specific line, generate pipe isometric. This automatically generates all the drawings it's not in it doesn't do it in straight to PDF. It generates DWG files that you can also go there and maybe add some annotation, but uniquely it come out with the required annotation. Maybe, well, you specify that in the dialog box before you generate the pipe isometric, but you have things like associated MTOs, weld details, equipment list, and all this stuff. Okay, and of course dimensions, which is quite unique and important. Okay, sorry, other thing, the final part of what the last slide showed, how easy it is also to generate layouts, projections as well. Okay, this also shows a little bit of what I'm discussing, especially around layouts. So you see, this is totally connected to the actual model. There is no disconnection between this drawing phase and drawing interface and the model itself. Okay, it's easy for you to tag the line because there is already a property defined beforehand. So you have a drawing that is totally linked to the actual model, and you can generate all annotations. You don't need to estimate. You don't need to start thinking or wasting time to confirm what detail is here or there. So it's very easy for you to link. So this is also a workflow for generating pipe isometric. Specify the lines you want with a click of a button. You see some set of PDFs, sorry, DWG files are generated. So this is how it looks somehow. So everything is totally annotated for you, and you can regenerate them if you're not satisfied, or you can also add additional annotations. So that is for the early stage. Another thing we discussed was reality capture. I'm going to be very quick here because I know someone is supposed to cover this scope as also. This is unique for brownfield projects. Okay, reality capture is, of course, as we all know, let's say your project, you need to capture the present condition of the site. It's very easy for you to just float, some scanners, be it drones. I don't know how this, depending on the scope, that determines the equipment you use. But all of this help you maybe go to site, capture the existing condition of site. So what you just have here is, of course, an application from a different space, but I just wanted to just project, the whole idea. So which simply gets you to use a scanner, scan the entire site, acquire that data. Of course, there are also some pre-processes or post processes that you have to do to clean up the scan data, and then get it into your design interface and use it for whatever reason you intend to use it for. For some people, they just want to probably use it to generate attribute drawings. Some people want to use it to they just want to use it as a reference to a couple of renovation works. So, but at the end of the day, the workflow is simple, right? Whatever you're using, whether you're using scanning, 3D laser scanning process or photogrammetry, the objective is to capture, all right, and get it into any of the solutions. So there are a couple of solutions like Navisworks, Inventor, Revit, and so on and so forth. So whatever you do, you just capture it there. So there is a solution at Autodesk for that called Reality Capture, which literally help you coordinate, all of those data. And at the end of the day, as I mentioned, there could be so many reasons. So this is just a typical application that relates to this space. Okay, so things like this, of course, this was captured by photogrammetry, and recap could be used to coordinate this into an actual model, a lesser scan model, and from there other decisions can be taken. All right, other things can be done with the model. That with all of this, you can take dimensions, capture how it is, and then probably come up with your innovation. So that's about it around the plant side. And I just want to quickly also run you through a couple of the structural design workflows. And this is actually where Autodesk, collection like the AEC collection becomes quite unique, because you don't necessarily have to do the same thing, do everything in that AutoCAD. All right. There are other solutions that are specifically built for maybe structural design. And uniquely, as Autodesk would have it every time, it's not just about the design process. It's actually always about what happens downstream of your process, all right? How are you getting your drawings out? How quick are you generating maybe quantifications? How, of course, not just how quick, how accurate are they going to be? And of course, when there are time for changes, how do you need to do that? So basically, the business challenges are unique, just like what we discussed. Complexities are everywhere. It's very easy, all right? And second point is partly what I just mentioned. Yeah, somebody just spoke. Sorry, we have people online. Is that a question for me? Okay, I assume is that it's just a noise. Okay, so the second point, which means disconnection between the design workflow and detailing process. So this is, quite unique. Most workflows people have always disconnect design from detailing. All right. Sometimes, yes, they have a process for detailing, but you notice that there is no form of connection. All right. Data intelligence are totally lost, right? Once they start heading down to detailing. And of course, every other thing we mentioned here before, waste, error, delays, and of course, unavailability of skills. So these things are quite profitable when you start looking at BIM, but looking at this space, just like we saw during the plant space, not for buildings, okay? You see that uniquely at the early stage, we want to come up with models, designs that are unique, that are parametric, they are very easy for you to collaborate with people. Okay, and this at this early stage, it's important to have that multi-material structural model interface like what you have with Revit. So Revit is one of the solutions contained within the AEC collection. And what it typically does is it gives that multi-discipline design interface. By multi-discipline, yes, it's widely used by the architectural space, yes, because it has the Revit architectural space interface. But apart from that, it has uniquely the Revit structure aspect of it, which provides intelligent parametric design workflows. You're able to connect your structural design to the detailed model. All right. And of course, you can extend as far as having your analysis, quantifications, visualization, coordination, and some level of analysis. So a typical Revit interface looks like this. And I wanted to go straight to beyond what you already know, because certainly Revit is going to help you do have intelligent structural design, all the joints smart and very quick. But you see, it's very easy for you to start generating schedules, documentations. All right, you can start building up your cut list like what you have on the screen. So with this, it's quite very easy. You can sort by anyhow you want it. But one good thing about this is also it's not generating this deliverable as something that is totally disconnected from the model. They're all maintained and stored within the browsers, so you can easily access what you have. So you can also have schedules for the connection points. Okay, all of your anchors, whatever it is, all your connection views. So it typically have help you coordinate that. So, but I want to also point you to a solution called Advanced Steel, all right? Steel built within the AutoCAD environment included in the AEC collection. So, but uniquely, one thing about Advanced Steel, it takes steel design, steel structural design to another level, especially with development of detailed drawings, especially with detailing and shop drawings. So it has the similar interface with just like the AutoCAD, and it has all of the necessary modules, all right? And with unique tools or like joints, you can see how easy it is for you to create a seamless joint connections. So other things included in this other things you also might be interested to see is probably generating all of the deliverables, all right? Not just this model features, of course, things like your ability to come up with cut lists, all right, ability to come up with maybe if you're working with a lot of sheet metal design, like in what you're seeing right now, how you generate patterns, drawings that you can, patterns, DXF files that you can use to go ahead with your sheet metal workflows. So, but one unique thing about Advanced Steel and the likes and Revit also is that they have in-process analysis too. So as you're modeling, for example, you're modeling your joint, it's very easy for you to quickly analyze that joint and ensure they are up to standard. So all of those special aspects of structural design like access, stairs, ladders, gratings are all available, and uniquely they are quite intelligent, unlike a couple of solutions you might see out there. Why I mean intelligence is that changes made to one aspect of it can actually be leveraged to update the other ones automatically. So that is something you might want to learn about this. So there are other workflows that you have, right, from gratings to railings to ladders to stairs. All of those things are all available. So one might want to ask, okay, how do you integrate all of this into one model? It's very easy. And as you're using the AEC collection, you see that all of them fit. You can, superimpose all of them into each other and have a unified environment where all of this project sits. Okay, I think one of our presenters, Edwin, we also mentioned, we also discuss things around how design disciplines can coordinate, all right, why these projects are going on, because of course there are a whole lot of scope of project. How do everybody speak to each other? Is going to speak a lot around coordination. So, but this, what you're seeing right now, so buttress is what I mentioned about how intelligent all of this interface are. So you do not need to remodel everything when there is call for changes, all right? As this is going on, a lot of specification are being made. Well, specification are being made, changes are made, all right. But what happens when maybe the platform on which the railing sits, you see, as for example, this is drag, you see automatically all connected infrastructure automatically updates accordingly to help you save time and remain compliant. So a couple of other things already mentioned, or how you can easily in process calculate, ensure that your model is up to standard as you go. All right, so these things are very important. Okay, going to quickly shift. So the next thing is also things like analysis, all right? When you want to engineer your model, you want to be able to conduct some FEAs, right? You want to be able to optimize your structure for code checking and so on and so forth. So there is also a solution within this collection called robust structure analysis, which is more or less an FEA tool. FEA means finite element analysis for analyzing your infrastructure. Okay, so the workflow also is smooth and seamless, all right? Everything is end to end. So originally this model has been going on Advanced Steel, and the objective is to just quickly analyze the integrity of that particular beam. So typically what is required is to just move between Advanced Steel and the likes of robot structure analysis, where you just quickly into how you might want to optimize the model. So it's very easy. It's quickly gotten into Advanced Steel through a simple workflow. Is this moving? Okay, into a simple workflow. Okay, and it just involves, exporting. This is how the environment looks for robot structure analysis. When you get the model in, of course, as a basic analysis or FEA engineer or CAE or simulation specialist, is just basically to do a couple of conceptualization around your FEAs, define your boundary conditions or any other condition, or more like all of your ideation. And of course, interesting discretization needs to happen as well. But at the end of the day, when you're done with all of these conditions or whatever you need to specify, all right, considering your actual environment, okay, you now analyze this model. A simple simulation is done, all right, not necessarily simple. I'm just calling it simple because of how interesting the solution is. So when you're done with all of these, your calculations are done and you have a result. Now, one good thing about this is that you can now quickly take this back into advanced steel, for example, and this is, of course, a simple workflow takes it back to advanced steel without breaking in the connection. So it gets into advanced steel and now gives you an advice on what happens. So it gets back into advanced steel, gets attached back, and of course there are a lot of red flags, but look at what happens when this is applied back. You see there are a couple of flags around where there are a couple of issues. And considering that the advanced steel is also a high-end structural design solution, you see that it's also very easy for you to quickly, all right, recommend the solution. You see how easy it is for you to add joints, all right. You can also iterate on some basic feature around the gussets or joints, whatever it is. Probably you want to play around the kind of plate or the number of bolts required for that particular joint is very easy. And the next is I want to quickly run to design verification, all right? And that's what typically looked at, and documentation and so on and so forth. So this often happens between Revit and advanced steel, all right? Most times people use this intermittently, all right? Any of this works, but I mean, whatever you do from Revit, for example, you see it gets it's now moving into advanced steel, uniquely maybe because of the best features of advanced steel. So you see something about the model that came in from Revit maintains its intelligence. Okay, let's say, for example, you want to look at this joint connection. You see, it contains the necessary information you need, and you can now decide to make changes as you require. And now this is where it becomes interesting, generating probably cut list, saw list, with all the necessary information. So you can quickly generate all of these, all right? An example would be, maybe I want to look at all the plates, all the sheet metals involved with this model. You see, with a click of a button with the sheet metal feature, you can quickly generate, identify every single thing that is sheet metal. You see all of them are already in an NC file. If you can connect, that's fine. But generally, uniquely, what people use is DXF files, send it to their programmers, or laser cutters or CNC lasers, and they quickly get it. But apart from it, you can go ahead and detail a couple of other things, right? Some automatic annotations that quickly generated. It's built in the, as I already mentioned, this is built, all right, within the traditional AutoCAD environment. So you can just quickly use your commands and add any annotation you want to do. But, at the end of the day, this works. I do not want to also emphasize the importance of revision management, because, of course, in a typical environment, these things happen, changes are going to be made, and we need to track all those kind of changes. So it's very easy for you to maintain all of these. However, there is also wonderful innovations that Autodesk can help you manage this with our cloud collaboration system, which Edwin will also mention later on today. He's already standby and waiting for us. So after that, what you're now worried about is, how do you coordinate? Because there are so many stakeholders on the project. There are people from the fire safety team running their piping, the HVAC team running some couple of pipe, whatever it is. Everybody's working together on the project. You want to make sure that everybody speak to each other, everybody coordinate. You don't want to get to site with surprises. So that is where solutions like Navisworks, still included in this collection, come into place. Firstly, it's very easy for you to integrate your conventional schedulers. Okay, maybe you're using Primavera or Microsoft project. You might just want to import your schedule, link them to a couple of workflows in your design, so you can quickly do as much as 4D, 5D analysis of what you're doing. You can have an overview of your model, create sections, all right? But sorry, I don't know, there is a sound. Yes, just please check the sound. Yeah, thanks. Okay, so as I was saying, all of this can quickly be done within Navisworks. Obviously Navisworks have earned its reputation as one of the best solutions for design review. And you see that it's very easy for you to not just do those, but have overview, look around your model. So I think I'm getting to the end of my presentation, but this literally says it all, on the workflows around Navisworks. So when you look at it, a quick test is run, and it runs through the entire design environment. All right. Probably everybody have collected their data, within Navisworks. You run your test. It tells you how everybody is faring on this project. So if everybody is still in the same environment, you can query everything, ask for review, ask people to, make changes and optimize the model. This way, you don't get to site and get surprised. You don't get to site seeing some modifications and valuations that were not initially planned. So this is the measure of cost saving, time saving, material savings. Okay. And finally, I'm just wrapping up what I've discussed today. All right. And what do we go home with today? Okay. It's a simple. All right. It often starts with solutions like InfraWorks, all right, trying to map out, in reality, in context, what you want to do. At the end of the day, you do your design with all of any of the solutions. All right, they all speak to each other. They are totally integrated. Data generated by one is automatically, transition to, transmitted to every other person, and you can reuse them for meaningful and intelligent workflow. And at the end of the day, whatever deliverables you require, all right, from the system, like generating drawings, quantifications, analysis, and so on and so forth, it's easy to be done. So the entire workflow are all integrated into a one package or one solution, which Autodesk calls the Architecture, Engineering, and Construction Collection, which is a collection of software that has the end-to-end workflows for industry leaders like you. And my presentation, of course, today is it's a lot high level, to be honest, because we'll also be glad to probably follow up later on with specific follow-up presentation that will suit uniquely your environment. So whatever it is you do, we can look at how workflows within the AEC collection can help, what you do. So by the end of the day, it all covers all of the solutions. So I've mentioned a couple of things around the space: 3D modeling, P&IDs, structural design, equipment design, project visualization and review, especially with the likes of Navisworks. So in a nutshell, what you're seeing is, for general design and drafting, all right, the likes of AutoCAD is within this collection. For P&ID, I mentioned uniquely, and I know you could relate how intelligent our P&IDs need to be. We looked at AutoCAD P&ID, which included inside the AutoCAD, one AutoCAD that we have now. As I mentioned, AutoCAD is not typically what it used to be. It's specialized two sets, which includes the P&ID and Plan 3D. And we also looked at the likes of 3D modeling and documentation, all right, pipe isometrics, pipe layouts, site layouts, projections, and code, which you can do with Plan 3D. We also looked at structural design and detailing, all right. I like to emphasize detailing, which you can walk around Revit and Advanced Steel, all right, for that. And I mentioned Inventor, all right. Not necessarily that's the only solution that is not included in the AEC collection. However, it's important in the workflow. Maybe you want to generate frames, skids. You want to build a complete skid, with actual 3D mechanical CAD solution. And finally, visualization, coordination, design review. Navisworks heads that team. Okay. Sorry, I have a question here. Yeah. Yes. Yeah. Mm. Yeah. 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 Mm-hmm. Mm-hmm. Yeah. 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 Mm-hmm. Yeah. Yeah. Mm. Yeah. Okay. Mm-hmm. 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 Yeah. Mm-hmm. Mm-hmm. Okay. Okay. So firstly, there is always a middle point for integrating models from other software owners of let's say software generally. So typically, for example, there is this industry format, all right, that you can use, all right. People are already leveraging things like that to get their models into Navisworks, for example. Okay, but I think I will let a great part of your question be answered by one of the presentation that we have later on, all right, where we talk about coordination, collaboration across projects, all right, where you see Autodesk having some set of solutions where you can work with, you know, in other file formats, all right? You can even access them, open them up in the cloud, you know, but most times you have to probably come to an industry accepted file format. As for skills, of course, often there are workflows, all right, that will just need to get your skills, your team to acquire skills around that, okay? Things like P&IDs are probably the easiest because before now people are just using AutoCAD or the likes to do it. Just that now you have a more intelligent solution where you're not just drawing lines, but you're actually routing. Okay, and it's adding intelligence and you're building. So most of the time, the training people often get is more like a beam training, an attitude training to tell you that, oh, as you're doing this, something is building up some data for you. Sometime, you know, let's say you finish a whole site on P&ID, all right, you need to also understand how you can start assessing the data you just impute into the P&ID, like the valves, the lines, and all of those. But for integration, I would like Edwin to address that question. All right. I will also remind him, though I know a greater part of his presentation talks about how we work with, you know, stakeholders that are using other solutions. Okay, that's it. So I think this is even where my presentation ends. So I already gotten taking that question, but I will make sure that you have a better answer than what I've given you before now, even from myself as well. But the AEC collection generally speaks to a whole lot of solutions, of course. These are a couple of solutions that are included there necessarily. Not that this solution, I don't want to get into, because what people typically ask me, whoa, it's a lot. Isn't going to be expensive, but I don't want to get into that part. It's as cheap as having one of them also. But importantly, I wanted to point out some solutions that would speak to each other in your projects. All right, when you in AutoCAD, you have Revit, you have advanced steel. All of these solutions I've pointed out today, all right, all of them are totally, all right, interconnected. So what you're doing here can be assessed, all right, connected to what you're doing here. This can provide some level of intelligence to this side. Okay, so guys, thank you so much. I will take any questions after now. You can drop your questions, and CDSS also would also. Okay, people, can I confirm if anyone can hear Mr. Peter speaking on the microphone?
2021.
Can you hear him? I don't think they can. No.
No.
Okay. Okay, so wanted to fix a microphone for the audience. So any question that they ask, people online can hear it. Yeah. Yeah. So okay. So if you have any question from the online team, please do drop it in the chat. We will start looking at that now. Okay. It's all right. Yeah. Yeah. It's all right. So guys, so this is where the first part of the presentation stops. We're going to take a 15 minutes tea break here. Please feel free to grab your coffee from your side, and then as soon as you're back, Edwin will start up with his part of the presentation, which is on collaboration or collaboration on engineering projects or something like that. Okay. Thank you so much.
All right, everyone online. Hello. Hello.
Hi.
Are we also there?
Hi.
Yeah.
Hello,
Good.
we are here.
Yeah. Please put your questions in the chat. We will take a 15-minute tea break right now. That's till 11 o'clock. Then when we come back, we will answer your questions. And then we'll go on to the next presentation coming from Edwin Atiogoba. All right. 15 minutes. Thank you very much. Don't go away. Just 15 minutes. We'll be back. Thank you. Okay. Yeah, 15 minutes break. Yeah. Julian, I trained him 30 years ago. Yeah, you're too kind, Isaiah. You're too kind. Yeah. Something. The big part to pass for PDX, and my patch. But 12
12,000 euro then on projects, which are the $10 million will get out. What it is. It's actually embedded in it. Then embedded to come together. And we are nine. The government people are saying we invest it. Something I know. Thank you. That I can bring in file from to people their messages. Yes, the process. I'm going to show you. I'm having a discussion with watching nothing that you were guessing. There's a good